Almost anything that petrochemistry can do, biology can do better.
Hey, Carl, how's it going?
Iram, things in New York City are crazy. The whole city was shut down. And as we record this, it's a Monday. The city shut down for the snowstorm. So that means there's no school. And Grow Everything listeners, if you hear any little ones in the background, that is Iram's son because he doesn't have school.
Yeah, he's in the background. Oh, there he goes. He's talking to his dad. We're all home. But schools were not completely shut down in the sense that there was still remote learning for some grades. My son is in pre-K, so he had remote learning for 30 minutes. I think that's all
Wow.
they could do. And he did a good job. He's in pre-K 1, so he wanted everyone to know that. But it's great. I mean, like, I feel that I was really prepared for the snowstorm because we have a great mayor, Mayor Zohran Mamdani, who had been very clear on what the plan was when the snowstorm was coming. So I was really impressed by his videos on Instagram where he was taking us behind the scenes. Like, sometimes you're like, what does a mayor do? Like, what's their job?
Right.
How are they responsible for the snow? And like, what do they exactly do? And so there's this Instagram video, and we'll put in the show notes, where Mayor Mamdani went to where all the snow plows were stored and gave everyone a tour. And the way he talks about it's like, look, us New Yorkers, we're all in this together. Look out for your neighbors, like, do your part, and we can have a fun snow day. And that was great. I mean, I listened. I mean, I did go out a little bit, and my husband and my son are pretty mad at me for getting them out because it was freezing rain. So that hurts, you know?
Yeah, that was late. So it was snow first, then freezing rain in the afternoon.
Yeah.
So I can see why they'd be angry at you.
Yeah. But no, now we're chilling. And here we are on the Grow Everything podcast talking about how biology is transforming every industry. So what do you got in the news for us?
I do want to just make one comment about the mayor and actually the governor too, because this snowstorm really hit the whole state. What was cool was both of them talking about shoveling snow. And most of us don't shovel snow very often unless you're living in a place where it snows all the time. And both of them had this warning. Hey, if you're going to go out and shovel snow, be careful. People have heart attacks. And even Governor Hochul got in front of the podium and showed the right way to shovel snow, which I've never seen before. So I was very impressed by both the response and the two of them just talking to us about what these kinds of snowstorms mean. So yeah, they've done a really good job to prepare New Yorkers for this particular snowstorm.
Yeah. I will say one other thing too.
Yeah,
is
go
that
ahead.
one of the things I do worry about when it's really cold outside and there's a lot of snow is people that don't have homes, so homeless people in New York City. And they were also advocating, like, if you see anyone, here are the spots where they can go. All these shelters are open. Everyone's going to be accepted. And then there were people out looking for anyone that was not in a warm place. And if they didn't want to move, they provided them with extra blankets and socks. And it was just like heartwarming to see that everyone was rallying together to make sure every New Yorker was safe. And that was beautiful.
Yeah, and it was in the morning. I went out several times during the course of the day. I did have to shovel snow, but I went to the grocery store and I went to the hardware store, which just happened to be like a block away. So it's not like I had to go very far. But the snow was already like 6 inches deep and the streets were empty except for the guys making deliveries. So bless those guys because they're tireless and they keep working even on the snowstorms. Though I didn't see as much activity as you normally see with those guys on bicycles or on electric bikes, but they were out there delivering for New Yorkers. So today, Monday, there is no school. The city is somewhat shut down. And we're lucky because we can record these podcasts from our homes. Now, to just get into some Grow Everything related news, you pointed out, Iram, and I heard it too, that Kara Swisher on the Pivot podcast mentioned that she'd had a conversation with a tech CEO. And she was like, these guys are going to be buying up healthcare companies. They're going to be buying pharma companies. And I think that that's a dialogue that you and I were having back when we started the podcast, because there was talk about who's going to be the first $1 trillion biopharma company. And it turned out Lilly and Novo got there. I think one of them did, Lilly did. And I'm going to share two examples where we see this. And the reason why tech is investing and going to probably buy up pharma companies is for the data. There's so much data that is generated by biology. This is something we talk about a lot. And I'll give you two examples. But do you want to comment on that before I give the examples, Iram?
Yeah, I mean, this was a very prescient thing that we talked about because we were seeing some activity happening and through our own efforts with our clients, talking to pharma, and some pharma companies do outsource a lot of their work across drug development. And really, some of them start becoming more of what we like to call orchestrators, that they have different contract vendors, manufacturers, people that do toxicity studies, and they kind of just orchestrate the drug development. So it's a collaborative effort. And the challenge is making sure you get data across all activities so you can have this closed loop, feedback loop on drug development. So you're making a drug that's towards the right target, and like you're saying, yes, the data is an important part because everything else is logistics, so there really isn't that much of a secret sauce anymore. And pharma has been accused, and I've seen inside a lot of it is, I want to say, spaghetti on the wall because there's an idea, there's a target, there's obviously a lot of very intelligent medicinal chemists working on designing a drug, but biology is complicated. So they have a great prediction and they do get it right. Sometimes obviously we have drugs that work, but there are side effects. And so sometimes, depending on what drug it is, there are drugs that work brilliantly. And, kudos to those pharmaceutical companies that have made drugs that have no side effects that work very effectively. That's when they rake in the dough and they get rewarded for that. But to have tech come in and be able to look at this playbook and say, okay, well, let's make this a tech forward type of endeavor, and then partner with pharma companies as vendors to develop drugs.
Okay, so let me give you two examples of tech moving into biopharma. The first was a $500 million deal between Andreessen Horowitz and Eli Lilly to invest in new therapeutic platforms and technology companies that can bring new medicines and diseases to improve patients' lives. That's a lot of money. And those two, Andreessen and Lilly, are powerhouses. So I'm really looking forward to see how successful they are with this fund.
Yeah, also, just because it's Lilly, during JPM, there was that big announcement or conversation between Lilly and NVIDIA. And that's another big signal that there's going to be a lot of tech coming into and partnering and maybe possibly owning pharma. So I wanted to point that out as well, as we're talking about Lilly.
Yeah, that's a great
Yeah,
word.
and so just as a reminder, Lilly is a pharma company that made Zepbound and Mounjaro, which is the equivalent of Ozempic and Wegovy. So they are raking in a lot of cash too. But wow, those are two heavy hitters that are partnering with each other.
Yeah, and another, which maybe is more relevant to some of the tech that we talk about here on Grow Everything, is this deal that Indigo Agriculture did with Microsoft. And those are two heavy hitters as well. Indigo Ag is known for making seeds that don't need nitrogen, so not requiring the kind of fertilizer that a lot of crops need. And they partnered in a 12-year deal for soil carbon removal credits, which I think is super interesting. So again, big tech is coming into pharma. We're going to be reporting on it as this goes forward. There's a lot of opportunity for tech to help the biopharmaceutical industry. And at the same time, there's a lot of opportunity for big pharma and biotech in general to generate data that big tech can use. Now, let's get into the fun story. Iram, you're the one who flagged this one and you sent it to me over the weekend, and I thought it was so fun.
Yes, well, of course. I mean, it was a Mr. Beast video. Mr. Beast gets all the views, has all the eyeballs. And wow, for this one video, which we'll put in the show notes, was about going from a $1 innovation to a $1 billion innovation. And a lot of it had to do with robotics, cars that are very interesting. Like $1 one was like a little light that could be used for places that don't have a lot of light. It's like $1 light bulb. But then it went all the way up to $1 billion, which was a rocket ship that would go to Mars, right? So they interviewed all of the companies that were making these innovations. And two I wanted to flag was Upside Foods. So Mr. Beast went to the factory and met the founder and tasted the Upside Food chicken, which was made through Biomanufacturing, of course, and talked about it, which I thought was really great because this video was released yesterday. And so we recorded this a while ago. And in one day, 50 million views. I mean, it's just incredible. But the big thing that Mr. Beast did too was he went to Colossal. So Colossal, we know we've had people that are affiliated with the company. We had them on, and what Colossal does is they're de-extincting animals. So people might be familiar with Colossal because of the story of bringing back the woolly mammoth. And through their research, they created woolly mice, which are actually very, very cute. And Mr. Beast is behind the scenes talking to Ben Lamb, the co-founder of Colossal, and Mr. Beast is holding a woolly mouse, and he got a gift for the dire wolves because that was another big story that happened on the cover of Time magazine, that Colossal brought back the dire wolf, which is the saying brought back is weird because it's like, oh, did you go back in time and grab it? But no, they
Right.
edited the genes of probably a regular wolf to have those genes express the same phenotypes of a dire wolf. It was really cool because Mr. Beast isn't a scientist or a biologist, but he was wearing a lab coat. He was actually doing gene transfer, which was incredible to see that in a very popular setting. So he had the microscope, and he had the nano syringe. I mean, I don't know the term. Sorry, scientists are like, Iram, it's this, but I forget what they're
Right.
called, but it was like inserting genes into a cell. And, it was just wonderful science content that was like, yes, finally, let's get more into the mainstream. Nothing more mainstream today than Mr. Beast.
I was all for it. It had some really great little animations and the way that only Mr. Beast can do this. And I was like, if this is what it takes to mainstream biotech and using his style, then I'm all for it. I always say we need a lot more of it. And, kudos to Mr. Beast. Kudos to Upside Foods and Colossal for appearing on there. Also, Neuralink was on there. That was an incredible segment right at the beginning. Super cool to just see all of that. And the number of views just speak to how much people want to see what's right ahead of us, because it's really about future tech. And a lot of these techs are being developed and are very close to being on the market. And Ben Lamb says that we will have woolly mammoths by the end of the decade, which is in a short 4 years. So that's amazing.
Yeah. Very good. Everyone, highly recommend watching that video. Again, it's in our show notes.
Yeah, so with that, let's get into our guest today. Our guest is Joshua Lachter of Synonym, and we've had his partner and co-founder, Edward Shenderovich, on the podcast in 2025. So we thought it would be a good idea to catch up with Joshua and hear what kind of progress Synonym has been making. Do you remember when we first met, Joshua, Iram?
I don't remember, but I see in the notes that you have you have that. I don't know if I met him or you met him at C16 Biosciences. Were we there together?
I think we were.
Yeah.
I don't know. Now I have to go back. I'll have to go back and look at the photographs, but I know for sure like Amanda was there, John Cumbers, Suzanne Lee, a bunch of people that we know. So pretty sure you were there.
Yeah, I feel like I met Joshua through Edward at Biolabs because they had a space there, and I know they're moving now to another space. But because we're in New York City, and so is Synonym, we get to meet Joshua, Edward, their team regularly. We've co-hosted events together. I was just like, why haven't we had Joshua on? Edward has been actually the number one episode across all of our episodes. It ranks really high, has a lot of listens. It is an industry developing episode. So we'll definitely have Edward's episode in the show notes so you can grab that really fast. But let's not wait any longer. Let's let Joshua tell us what's going on at Synonym and what's new and what has he learned from all the efforts across what the company's doing.
Joshua Lachter of Synonym, we're so happy to have you on the Grow Everything podcast.
Thank you for inviting me on.
You are the co-founder of Synonym. We've had your partner, Edward Shenderovich, on before, but would love to give some background on you and what the problem is that pulled you into co-founding Synonym, which is a biomanufacturing platform. Why did you feel like that was urgent enough to change whatever your career trajectory had been to build this company?
I'm not a scientist by training or frankly talent, although I have a lot of interest and love of science and scientists. I worked mostly in finance and later in artificial intelligence software. And when Edward and I began more seriously, we had known each other and when we early in the pandemic began kind of flirting with these ideas of starting a company, and there were a few ideas floating around. The thing that drew us to biomanufacturing seemed to be a kind of secular shift and a kind of very immediate need. And the secular shift was what we didn't call then, but we've come to call the Great Reformulation. And I hope we'll talk about that in a bit. This idea that more and more of our stuff would be created differently and created with biology, and the infrastructure to create that, to actually make those bioproducts, and this was the immediate need, simply didn't exist at the scale required to meet the demand. And so our feeling was there was a new generation of companies, many of which you've featured on the show, who are making extraordinary products across industries with applications in chemicals and food and agriculture and apparel. And the infrastructure necessary to actually get those products to market and in consumers' hands just wasn't available. And there would need to be not only a bunch of steel in the ground, but more broadly, a commercialization platform to bring those products from where they were today in 2021 to ultimately consumers, to commercial viability. And that was the opportunity that led us to found Synonym.
Yeah, it's incredible. And we'd love to talk more about the Great Reformulation and Synonym, but a little bit more about how you arrived here. So now you're in this field of biomanufacturing, and you mentioned you have this experience in finance and AI software. So let's talk about those two experiences and how did it help you think more about this commercialization of biomanufactured products, think about scale, and also when biotech leaves the lab into commercialization, like how did those two specific experiences of AI and finance help you think about this? And actually, you guys have brought so much to this space. We'll love to hear a little bit more about that.
Well, some of my experience in finance demonstrated the centrality of finance to getting anything done. And so, to the extent that these products would become mainstream, I knew that there had to be a kind of financialization of the means necessary to bring them to market, which was infrastructure. And until there was meaningful financialization, until these facilities could be built at scale and financed in a kind of clear and consistent manner, it would be really hard to achieve mass adoption. For me, we were fairly early in AI at my last company. And I think we were very much in the trenches of a technology that felt urgent, that felt like it was going to touch all our lives, but that needed a lot of work to feel real. And early on in 2014, 15, 16, the term AI was obviously known, but it wasn't certainly what it is today and ubiquitous in all our lives in so many ways that maybe we couldn't have foreseen, or certain folks foresaw, but not everyone. And so, broadly speaking, I think in 2021 and to an extent today still, the opportunities of biomanufacturing, the urgency is where other industries were 7, 8, 10 years ago. And I'll also say, even though I'm not a scientist by background or training, I've had a lot of exposure to science. I've been a small investor in a bunch of really interesting companies in the space. I was introduced to the term synthetic biology in 2011 or 2012 by someone named Nina Tandon, who started a company called Epibone, which you guys might be familiar with. And I was an early investor there. And the sort of broad idea, this sort of magical idea that you could take the best of biology and scale it to solve lots and lots of everyday problems was kind of a magical, and still is a magical idea. And I love the idea that, hey, we can now be part of that in a very broad array of applications.
So a core part of your thesis for Synonym was that facilities needed to be standardized and 90% usable to unlock project finance. And you guys were the first ones who I ever heard talk about these biomanufacturing facilities being an asset class like data centers, which I was always impressed by. And as soon as I heard you guys saying it, I started repeating it to other people, and that perked a lot of ears up. Do you still operate under that thesis, or how has it changed?
To us, the standardization of facilities needs to happen for mass adoption of bioproducts, and to an extent will happen. It hasn't happened, frankly, as quickly as we would have hoped. And I know a lot of folks in the space share frustration with the pace of some of the projects and the pace of adoption of bioproducts. But part of our core thesis was not only that financialization and standardization go hand in hand, it was that demand is ultimately really the key catalyst. And part of the thing we've tried to unlock is this interplay between demand signals and technological progress that you've had lots of Fortune 500 companies featured. You just, I think last week had Procter and Gamble on, and they're doing amazing stuff in the space, as they talked about. For companies that are really big and operating on true commercial scale, the pain of making a miscalculation on a key ingredient is massive. And so part of what's really hard and what's been hard for the industry, as we've all had a front row seat on, is getting those demand signals are key to unlocking some of that financing and therefore that standardization. And they go hand in hand of the facilities to make the product. And some of those off takers, some of that demand is reluctant to make those commitments before they see certain metrics met. And so I think to some extent, the industry has remained on a kind of, pick your analogy, unicycle on a basketball kind of thing, trying to manage hitting milestones, which are very expensive in biology and hard, especially at larger and larger scales, to prove to the off takers that they can do it, and while simultaneously trying to hit those metrics, right? That you need continuing demand to hit metrics, but you also need to hit the metrics to get the demand. And that kind of feedback loop has been a challenge for the industry. And we remain of the belief that, again, as mass adoption comes, and it starts as a trickle inevitably, but grows and grows and grows. And there are certain secular forces you've talked about on the show, GLP-1s, for instance, that are beginning to unlock this idea that bioproducts are really potent parts of our lives. But ultimately, there is not enough capacity to fulfill that if we believe that adoption will be what it is. And there will need to be standardization and financialization of those commercial assets. And we continue to see that as inevitable. The timeline is a little up in the air.
Yeah, that's well said. We talk about that a lot with the innovators. I mean, again, we did have these bigger companies on, but this chicken and egg, so, what comes first, right? Demand side, or making that decision that we are going to go for it. And you have talked to so many different companies, just from your own learning about what's going on in the industry. Synonym also provided some software tools that these bio innovators could use to financialize and come up with LCAs, the life cycle analysis. It was, incredible stuff that you guys have really helped the industry really think about biology or biotech commercialization from an economic standpoint versus just, a science a project, right? And that's been an incredible driver, I think, for this industry as it's continuing to grow. But I would love to, you talked about this, but what are some other early assumptions about biomanufacturing or commercialization that turned out to be wrong in your perspective? This whole demand thing, people do want some things, but maybe some of these larger players are saying, no, that's not the case. Tell us a little bit more about what you thought was going to happen and actually it wasn't the case.
Yeah, we were surprised and remain surprised at some of the opacity that exists in the industry, and have worked in these various platforms. And we have some stuff in the works that we think will double down on our commercialization work there that we'll be announcing soon, but to unlock some of that opacity. So, if you're a synbio company looking to produce your product, actually finding a place to produce is a very arduous and complex and opaque process. There's no really good database that exists of producers, of CMOs, contract manufacturers.
Hey listeners, Josh mentioned CMOs, or contract manufacturing organizations. These are third-party facilities that produce products on behalf of industrial biotech and biopharma companies. Instead of building your own factory, you rent expertise, equipment, and capacity. In theory, CMOs speed things up. In practice, finding the right one on bio is challenging.
And even if you can find one, actually getting a price that makes sense is a kind of very delicate dance. And so, Arun, you alluded to Capacitor, which we launched in 2022. And I think we found that was a response to, hey, it's really hard for anyone to know what production capacity is out there. And it's hard for the producers also to qualify who's coming in. Unfortunately, we've seen a lot of failure in the industry, and it's really hard for any real estate owner, but especially one in something like biomanufacturing, to take a bet on a company that might not exist in 6, 12, 18 months. And so part of perhaps what we underestimated was the opacity not only of some of the kind of mechanisms of production, but even in the equipment of production. So, getting things like equipment quotes is really hard. You can't just call up a company and say, hey, how much does this spray dryer cost? There's lots of back and forth. There's lots of hoops to jump through. And the complexities, and this gets back to the standardization point that Carl was alluding to, the complexities of standing up production, whether at a CMO or in your own facility, which is really, really hard and has been fairly rare in the last few years, has let, I think perhaps we underestimated a little bit. Our hope remains, and I think you've seen this administration make commitments to this front, specifically in bio, our hope remains that the broad bottlenecks that have sort of made the United States a laggard in manufacturing will slowly unstick, and that includes in bio. But we need to really get better as a country about building stuff, and that stuff includes bioproducts.
It's interesting because I just saw some news about how Apple has teams of people who are out there going into manufacturing facilities and helping people, improve their processes. I don't know how successful they are or if they're even doing that in bio, but I thought it was like an interesting effort, because there are people who say that basically Apple taught China how to manufacture and be as good as they are, which I think is super interesting. You've previously said that the fermentation capacity gap that people talk about, in other words, that there's not enough capacity for fermentation, is actually a perceived gap that's caused by this opacity you mentioned and also market friction. It's not that there's not enough fermentation tanks out there. As we move into industrial commodities, does that still hold true? Or are you finding that there still is this physical infrastructure that we really need a lot more of and that we need to build for these new verticals?
Longer term, there will certainly, in a span of 5, 8, 10 years, there will certainly be a physical steel in the ground gap between demand for production and actual supply. And in part, what the commission has done, and you featured members of the commission and lots of references to it, what the commission has done an extraordinary job of is highlighting the strategic importance of biomanufacturing and the need to start building today, because we're only losing ground every day. So in the sort of medium term, there will be that gap. Today, however, it is more of a perceived gap in the sense that it's not that capacity doesn't exist. The reason in part why certain capacity goes offline or shuts down is because it wasn't the right capacity for what's needed. And part of what the challenge has been, and what we've seen at Synonym and what we've tried to bridge, is this idea that capacity in general is not going to be turnkey. If you have food, for instance, if you had an idea, a room for a new kind of snack bar, I could likely have something on your desk in like 10 days for a pretty small fee, because there is a very mature, very agile, very deep bench of co-packers in the United States to make all sorts of food and lots of specifications. And because of that, it's fairly inexpensive to get started. That doesn't exist in bio. It's really hard to find the right fit. And so it's not that the capacity doesn't exist at all. It's that, is that capacity willing to take a bet on what you're trying to do? In food, there's enough of it and it's sufficiently mature that, again, the costs aren't that big for either side. The costs remain really high on both sides of this transaction in biomanufacturing. And until that comes down, there will remain a kind of, whether it's perceived or real, there'll remain this kind of inefficiency.
Yeah. I mean, perhaps you can ground us in how this works, especially with Synonym and maybe helping a bio innovator produce products. You recently started a project in Illinois. Is that something you can talk about? How things are
Yeah, sure.
progressing? Yeah.
We're really excited with how that's progressing, and thanks
Okay.
for mentioning it. So through in part facilitated by a loan through the Department of Commerce, the EDA, we are building with a partner in Illinois called Premiant. They're one of the largest wet millers of corn in the United States, an amazing company. And we're co-developing with them a facility in Decatur, Illinois, which we're really excited about. It's called iProof. And the idea is it's when it comes online, and hopefully next year, it will be really sort of top tier demonstration capacity. So this is sort of filling a gap in that we saw in general, having seen what's out there, of really state of the art capacity that could be a little more turnkey, that had everything that a company that was scaling up could use. And we're really excited about it. And we think, again, that part of the value of capacity like that is just showcasing what can be done, right? Showcasing, hey, we're in America's heartland. We're using American-made feedstock in corn, and we have everything we need to make high-value bioproducts right here in America. And to our knowledge, we're one of the only, if not the only, third-party developers of that capacity, that we're really taking a bet on the long-term growth of the space. And we're very excited for that project to progress and for companies to start using it.
Yeah, just quick question, So is this a brand new capacity, or is it reused and standardized for biomanufacturing?
It's a so-called brownfield project.
Quick pause there. Joshua calls the Illinois project a brownfield. He's talking about reusing and upgrading an existing facility instead of building from scratch. Greenfield is brand new, brownfield is reuse. In biomanufacturing, brownfield can mean faster timelines, lower costs, and less risks. So, sometimes the future is hiding in what already exists.
So it's a retrofit of an existing facility. This is all. We have more information online about it. There's been various announcements about it. We think that the solution isn't always to build from the beginning. The solution is to so-called greenfield. The solution is often to take what you have and make it state of the art and design it so that it really meets the needs of today's users, today's biomanufacturing users.
And at what point do you see biomanufacturers coming to you guys and, signing up for using the facility?
We haven't fully announced a commissioning date yet, and that's really, Premium will likely announce that soon. But our hope is that it won't be too long. In the scheme of biomanufacturing projects,
Right.
they take time, but that when it comes online, it will be of its kind, right? Just one of the leading facilities on the continent.
That's so exciting. You heard it here first. Josh, I wanted to ask, you guys, through your tools, have gathered a lot of data around finding fermentation capacity. You've helped industrial biotech companies run techno-economic analysis on hundreds of products to see what is and isn't economical. When you aggregate that data and looked at it, did it change any of your initial assumptions?
Our hope has always been that bioproducts can be a cornerstone of the global supply chain. And we still believe that's true. What's become clearer is that the majority of bioproducts have a long ways to go. There are certainly commercially ready, prime time, put them in your product today. They'll make your product better. They can do it for the same cost as what you were using before. Customers will pay a premium for them. You featured some of these products on the show. There certainly are products like that, Carl, but there aren't enough of them yet, is one of our conclusions. And part of our work has been to help companies. Part of our work on techno-economic analysis and feasibility, which is where we've spent most of our time and where we've developed, we think, state-of-the-art tools. Again, hopefully more we can announce on that soon. But, our work has primarily been to help companies cross that chasm and to be economically viable. And we've seen certain products evolve in that direction, but many more have not. And so we're not scientists ourselves who do that strain development. And you've had many on, right, who are designing those bugs, who are designing those processes. We do some process design, and so, we sort of are this kind of commercialization layer, and we leave it up to the ecosystem that exists, and it's expanding and improving and getting, frankly, more realistic, which is good. Some of the idealism that I think we all saw 5 years ago has been tempered and has been replaced by just sort of extreme realism about, hey, this is what's the state of the art today. This is where the commercial pull is. This is why it meets it. And I think that one thing that we've seen that's been great is the evolution from, hey, like, we want to make something that in the best of times is going to be really hard to be commercially viable and maybe never be commercially viable given the alternatives that exist, animal based or petroleum based, to, hey, we want to start with a really high value product that isn't very good anyway, that's petrochemically based, and we can do it better bio based. And that kind of realism shift has been very healthy for the industry and will result, we really believe, in the coming years in more and more products reaching the shelves, and ultimately in where I described previously a kind of vicious circle of, hey, it's really hard to convince the off takers that we're real and can do what they need us to do, to a virtuous circle of, hey, we've shown those off takers, those big companies, that we can produce at the scale, at the spec, at the price point that they're demanding, and they're just going to want more of it. And that kind of virtuous circle is really what will accelerate the industry in the coming years.
Yeah, well said. So you're deep in the ecosystem. You've seen so many different companies that are making a variety of products for different verticals. And what is the thing that you've seen that for biomanufacturing, what often fails in the commercialization process? There's a technology, the economics, timelines, there's coordination between players. You kind of mentioned it in the previous answer, but just wanted to hear your thoughts. What do startups miss is actually the question. What do they miss when they're trying to commercialize? And you're like, same thing, please, can we, as a collective ecosystem, can we get this right?
It's very hard in biology to do this, but the earlier that any company in any industry can do this, but certainly in biology, it would be great if you could, is knowing how much it's going to cost you to produce from the earliest you can in a company's history. And again, if you're producing widgets, you can get a pretty good sense pretty quickly how much it's going to cost you and therefore what your margin is going to be. And sure, it'll get a little cheaper as you can produce more in scale, but you broadly know how much that widget is going to cost, that iPhone, that whatever it is. And that hasn't been true in bio, that this kind of question of how much is my product, companies know what prevailing prices are for prevailing products. They really have precious little knowledge often about how much it would cost them to produce even at scale. And if there was one thing that we would ask of companies, and are hoping, we've worked with companies on this, but anchoring on costs and feasibility and techno-economic realities from as close to day one as the company's founding. In fact, don't go to day one of the company's founding without at least knowing a little bit of that answer.
Love that.
Wow. Yeah, I love that too. So you had written a piece called The Great Formulation. I was hoping that you would talk about it to give our listeners some background. But just at a high level, you argue that, red dyes, microplastics, and forever chemicals are symptoms. What's the deeper systems problem that's behind those? Tell us about the paper and what you're hoping to accomplish with that.
Sure. I wrote the essay early last year in the wake of some of the FDA's move to ban certain of these synthetic dyes. And I argued in the essay that the dyes, in effect, were certainly bad and that the ban was good, but that dyes themselves were just the tip of a very toxic iceberg. And that, very much risk mixing metaphors here. However, the depth of the toxicity in our supply chain, or at least the potential toxicity of our supply chain, ran far beyond dyes and into all manner of microplastics and VOCs and other kinds of substances that, while not definitively poor for human health, have enough signals to signal that they are to maybe not risk it. And I sort of argued, hey, like, maybe we take a Pascal's wager approach here is, hey, we don't know for sure if these products are harmful, but there's certainly some signals that they are. At the time, a paper had just come out showing that there was a measurable amount of microplastics that were accumulated in the brains of cadavers that, depending on how you measure, like a straw's worth of plastic. So imagine having an entire straw worth of plastic in your brain. Not great. I think we can all agree, not great. And you could say, show me the study that shows that having a plastic, a spoonsful or straws full of microplastics in your brain is bad over the long term. I don't want to participate in that study. I don't want to know the outcome of that study. I'll just say I'd rather not have it in my brain to begin with, or any other vital organ. And if we take a kind of Pascal's wager view.
Whoa, hold on. That's a philosophy reference. Pascal's wager is a decision-making idea that says when the risk is huge and the downside is irreversible, you don't wait for perfect proof. Even if you're not 100% sure something is harmful, you act cautiously if the potential harm is big enough. In this context, Joshua is saying if petrochemicals and microplastics might be hurting us and better alternatives exist, then waiting for absolute certainty isn't rational. Choose the safer bet.
Which is to say, hey, we don't know for sure if they're bad, but there's enough signals, and I'd rather go for alternatives because they exist. And what I didn't really have time to talk about in the piece, and what is traditionally the pushback against some of this worry, is that the alternatives are there, they're good, and in fact, they're likely superior. So that the traditional pushback against something like microplastics is, well, sure, yes, there appears to be potentially some risks and some places that they show up that we maybe wish they weren't. But think about what plastics have done for society and for medicine, and have really formed the cornerstone of much of what we do in material science and in our daily lives. They're ubiquitous in ways that, documentaries and articles, and we know from our daily lives, they clearly are. My argument would be, and this is core to the idea of the Great Reformulation, that it's not that plastics are themselves necessary in any way. Their function is useful, but that function has existed and essentially mimics things that biology has and can do already. And so rather than try and go down a path of an inferior product just because it's cheaper to meet some functional need, let's meet those functional needs. In fact, let's exceed our perceived functional needs by using bioproducts. And that a cornerstone of the Great Reformulation, and I don't get to argue this in the essay, but I'll argue it here, the cornerstone of the Great Reformulation can and should be biology. That anything, almost anything, and I haven't been able to think of lots of examples, but almost anything that petrochemistry can do, biology can do better. And can it do better today? Absolutely not. Is it economically viable today? In all cases, clearly not. But over time, both for our health and for our general need to always have better products instead of inferior products, to move from whale oil to kerosene, which was clearly better, and even though it was a petrochemical, like clearly better than whale oil, to move constantly to better products means to embrace bioproducts. And I think you guys have been at the forefront of featuring founders and members of the ecosystem who are bringing those products to market. But it seems obvious to me that these products should increasingly form the anchor of a reformulated supply chain and of a reformulated world.
Oh my gosh, well said. I mean, listeners, this is why we have Joshua on our podcast, clearly singing a similar song, the same song, growing everything. You can use biology to grow everything. So thank you for that. And I just love the phrasing, the title, The Great Reformulation. We've formulated, let's reformulate. We have all these tools and knowledge now at our fingertips, and we can do it if we have this coordinated effort. Pricing is a very funny thing. I mean, yes, there are costs of making the goods, making the actual products, but who's pricing that, and can there be subsidies? That all happened for the plastics industry, which is the petrochemical industry. Can we do that with the biology industry, the biomanufacturing world? So very well said. I definitely will have a link to the Great Reformulation in our show notes. But I would love to hear, what kind of reaction did you get from people, whether they're in the industry or not, from publishing this? Any type of specific feedback or patterns that you received?
I think that the response was generally positive. People intuitively know that doing things drastically differently than their grandparents or great grandparents likely doesn't end well. And we clearly eat and function and consume broadly in our clothes, in our materials, in everything we do and touch, things that are drastically different than our great grandparents. And I think part of the response that was positive was, hey, we don't quite understand what bio was because I didn't really get to make that argument, but clearly this backlash against a mass reformulation previously, and that reformulation was mostly from the 1940s, 50s, and 60s, hasn't gone well. And there's nothing wrong, and in fact, it's healthy for us to reformulate again. And I think, if I may, one of the things that wasn't even as mainstream then was just sort of beginning to catch on. But certainly, in some ways, 2025 was the year of the GLP-1 from a health perspective. That was sort of the
Totally.
big
Yeah.
story. One of the things that, and you've talked about it extensively on the show, but an aspect of the kind of phenomenon that GLP-1s represent, I think it's something like 15 or 20% of the US population is now on or has been on a GLP-1. One of the parts of the story that I think is lost is GLP-1s were, and this is fairly well known, were originally discovered or synthesized from a Gila monster, from a protein found in the venom of a Gila monster, which for various reasons adapted and evolved that sort of the protein that causes satiation and all the things that GLP-1 does. Great. This idea, and it's been true for decades, finding useful drugs and chemotherapeutics and other drugs from nature. But what's changed now, and what my hope is, GLP-1s will catalyze a sort of mass realization about that will drive a reformulation, is that biology has already solved so many more problems beyond satiation.
Yeah.
And they can be applied to so many applications. I mean, think of a vulture, right? You guys have seen vultures. You've been in the country. We see vultures all the time. To the best of science's knowledge, a vulture's stomach contains the most acidic acid known in nature. And naturally, because is eating all this carrion and it has all these bacteria in it, has a super acidic stomach. Well, why doesn't that super acidic stomach bleed through the lining of the stomach? What's on the lining of a vulture's stomach? Clearly a vulture stomach is different than our stomach because it's much more acidic. And so if we can figure that out, whatever molecule that is, whatever, and in the same way that we synthesize this one protein and got ourselves one of the biggest revolutions in health in GLP-1s, synthesizing those kinds of things, making those connections in material science will have similarly profound effects. Because the difference 30, 40 years ago, when we were already taking certain things found in nature to synthesize a chemotherapeutic, the difference now is that we could do it so much faster. The tools that we have now, and again, you featured these, but the techniques, the tools, the apparatus that we have today to translate things we find in nature to products we could use is better than it's ever been. And my hope in part is that, again, GLP-1s in part will spark a revolution of other products that are inspired from biology because they're just more effective. They're just better, and we deserve better products. We deserve things that function better than an umbrella today. It rained 150 years ago. People had umbrellas 150 years ago. They didn't have nylon, and nylon wasn't commercialized. And so what are the things that we can find in nature that are more water resistant, that create better umbrellas, that create better things for us to use every day? And let's commercialize them. Let's reformulate with them.
Yeah. Wow. I didn't realize about was it a Gila monster?
Gila
Yeah.
A Gila monster?
Gila.
Yeah,
Yeah.
I didn't know that. I think it'd be cool to see an infographic of all of these organisms and like how they created value and like how much value of like all these different organisms. That'd be a cool infographic. But there's so much value hidden in plain sight in the biology, in the real world. We just need to look. And yes, I love that you're saying that we have these tools at our fingertips. I'm going to say that, like, I think anyone could be a biotech founder with all the tools. I mean, obviously you're going to have to learn a few things, but it's
look at
making it
me.
easier. Yeah, just look at you.
Yeah.
Look at who we have on the podcast. You're a great example. So it's a great thing. So Carl, I'll hand it over to you.
Yeah, I mean, you touched on this a little bit, Joshua, in terms of the speed with which things could be reformulated. And I'm just curious, have you had any insight into, like, at a large company, large organization, like we've been talking about CPG a lot, having fast AI-driven manufacturing combined with this kind of reformulation philosophy, do you think any of that is changing psychology inside big organizations?
The psychology of big organizations is almost by necessity to be somewhat conservative.
Yeah.
That's a broad brush, but I think generally true for lots of reasons, not least of which, when you look at some of these companies, they're massive publicly traded companies. They release quarterly earnings. You have how many working days in a quarter? Very few. Biology takes time, scale takes time. And so the ability to sort of integrate these products into, and certainly developing them in-house and bringing them to market is hard. And so, you've talked about K18 in that example. So I think we'll see more of that, where if you can show that you can get a product to market and commercialized, even if you don't have the scale, but if it's on the market, if it's commercially available, if it's working, if customers love it, I think we'll see more acquisition from some of the big players, because it's hard for them to develop these products in-house and bring them to fruition. And that's fine and that's good. But it's, again, the challenge that organizations have beyond the sort of financial ones is, hey, like we're talking in late January, there was just another recall of a infant formula ingredient in lots of infant formulas, obviously really scary. These companies at scale have to be very careful about integrating new ingredients in a new piece of their supply chain, because they can't afford to have slip ups like that. And so I think the onus is on the products to prove themselves. But over time, fundamentally, if you could meet the spec, and that means something different for chemical companies than it does for food and ag companies, but if you can meet whatever spec that they need, whatever the prevailing ingredient is, if you could do it as well or better, and if you could do it at the same price, and doing it at the same price means doing it at the same scale, then our hope is, and our belief at Synonym is, that even large companies don't have a philosophical pushback against integrating new products. They know, and they themselves have been reformulators of a kind for their entire existences. Has there been stagnation to a degree? For sure. But they know that they have to continue to reformulate. And our hope in part is that some of these upstart players and some of the newer players in various markets will force some of the larger brands to take reformulation seriously, because they'll see that there's market pull.
Yeah, and you're saying for these startups to show the example is to commercialize, get into the market and generate revenue. That's how K18 did it, right? They built a company. They weren't trying to sell one ingredient to Unilever, right? For example, Unilever is who acquired K18. So would you say that a part of this advice is to just lead by doing, and then allowing these large CPGs or large players to see that you actually have a company, that you kind of figured everything out, you have revenue, and that's the great playbook that would work in the beginning?
Yeah. Again, lots of companies have tried to, in the synbio space, have tried to start brands and it hasn't gone well.
Yeah.
But the fundamental idea that, hey, if you can show that you can produce something that gets to market and that has some sort of consumer excitement and demand, that will always be a really positive signal to larger players, assuming that that thing is fundamentally different, assuming that that thing that consumers are drawn to fulfills a need that doesn't really exist in the market, and doing that at scale, even if it's a small scale, even if the company's not totally profitable doing it, even if they can't compete with the big player, I think that's a really good signal. And the more that that happens will compel larger brands to move and continue to take the space seriously.
So Joshua, you've been out there, Synonym have been working with all these different industrial biomanufacturers or chemical manufacturers, and recently you've created a collaboration with Brentag. Can you tell us a little bit more about what the company is and what this collaboration entails?
Sure. Brentag is an extraordinary company. They're the largest chemical distributor in the world, specialty chemical distributor. And I think the idea with the Better with Bio program, which we announced a couple months ago, is that Brentag was seeing pull from their customers. So obviously they have thousands and thousands of customers and huge market signals. And they were increasingly hearing from their commercial customers that, hey, what do you have that can do X, depending on the application and all of that? And do you have a bio version of it? And getting back to this idea of realism, these companies are not looking for something that will take 6 years of development or whatever. Brentag isn't typically in the business of selling things that don't exist, right? That they can't sell today. And so I think Brentag understood the promise and the excitement from their customers of bio and wanted to really be a leader in bringing those to fruition. And so starting with those that are ready for prime time, but also then working as a force in the market to bring more to the market to leverage their extraordinary existing distribution. And so we're really excited about the program. And the hope is, again, that this will be a way for more and more companies that hadn't considered bioproducts in their supply chains or hadn't known that a bioproduct could meet a particular functional or formulation need to discover bioproducts. And again, the more that companies hear about bioproducts and understand what they do, and there's a degree of education and evangelism that has to happen for sure, the more likely they will be to adopt bioproducts. And the more likely that they adopt bioproducts, the more end consumers hear and care about those products and then demand them themselves. And again, that becomes itself a virtual circle. So we're calling the program Better with Bio. Our contention, as I've argued here, is that in many applications, a bioproduct is superior functionally and without the toxicity. And so it's just obvious that as it meets feasibility and viability milestones, those products will be adopted.
Yeah, that's
Very
amazing.
cool.
I'm curious to know that this seems like you have buyers on one end, you have a manufacturer, you have you guys coordinating. There's also, of course, biotech innovators. Just to like walk us through what a good collaboration with Better with Bio would look like. So let's just say one of Brentag's clients are looking for red dye 40, like a specialty chemical, and Brentag doesn't have it on their shelf because they don't make it. How would the collaboration work with everyone? Can you walk us through what that would look like?
Sure.
Yeah.
It's obviously sort of three-sided in the sense that you need that demand pull, a company saying, hey, do you have something that meets this functional need, a surfactant, a protein, whatever it is. And I think what Synonym spent the last 4 years doing is trying to kick the tires on commercially ready products and helping to get them to higher levels of commercialization and readiness. And, the goal would be that Brentag previously would not have had a good answer to that request, but now would have a better answer. Now would have maybe not quite a catalog yet, but at least some options to offer to that company. And so, again, our hope is not just getting the requests from companies for a bio alternative. Companies don't always do that. I think because sometimes companies have to be shown. And so for us, we always want to put out the call in the ecosystem for the very best products that are commercially available and commercially ready and do represent a viable alternative to what's out there, to be part of the Better Bio with program, to come to us and to say, hey, in this application, in this sub-industry, whatever it is, we think we're better than what's out there. And we're biomanufactured and we're the same price or cheaper and we're ready to go. Give us a shot in your formula. And it starts slow, right? It'll start with some application testing and development, and adoption takes time. But advantage is once, as we've seen with the current generation of formulation that's lasted nearly 100 years, once things reformulate, they tend to stick around for a bit. So that's our hope.
I was going to say, we'll definitely put a link. It's betterwith.bio, but we'll put a link in the show notes. Thank you so much.
Great.
I just wanted to make a comment before we go on, because what you got me thinking about with this whole reformulation and having this conversation with you was something that one of the formulators at K18 said to us was formulating with biology is completely new. Like, we have to rethink what we're doing. And it's very exciting. It's exciting for the formulators, but it's exciting for the consumers at the end because these products are going to have that superior performance. So I'm very excited about this. And I think it's something for, our listeners to know. You might end up creating a great ingredient. The formulation is going to really matter. And ultimately, the goal is better performance at a good price. So, thank you so much for talking about that, Joshua. We're going to head into our quickfire questions. Yoram and I will alternate different questions, and hopefully you'll have an answer. We try to keep it short, but if you don't, that's okay too.
Great.
So I'm going to kick it off.
Quick fire. It's not long fire questions.
What's the harder problem, biology or organizations?
To me, they're the same problems because organizations are composed of people and people are biological. And so organizations tend to follow all of the shortcomings and excitements that biological systems follow.
Deep. That's really deep.
I don't know
Okay.
about that. Not the first to argue that, but yeah.
Okay. Most overrated promise in climate or bioinnovation?
Probably in terms of sheer dollars invested and dollars out, to an extent, biofuels. And we don't want to count them out yet, but I think there hasn't been enough material results in biofuels. And we hope that a new generation of biofuels company will realize some of that potential.
Yeah. Scale first or purity first?
If I understand purity to mean the realization of a certain specification, a certain functional specification to meet some application or functional need, I think typically that should come first because scale can often be figured out. They're in some ways equally important because, spec without scale is sort of a science project, and scale without spec is a non-starter, is a waste of time. So you really need both.
So, one word, you'd retire from biotech pitch decks forever.
2026.
Optimistic or cautious about reformulation timelines?
Ultimately, I'm very, very optimistic. Synonym is very, very optimistic. It will happen. It will take time. And I think that we're so grateful to all of those working in the ecosystem, and you, Rum, and Carl at sort of the nexus of it, who are working every day to bring these products to market. We think that reformulation can happen, should happen, needs to happen, and it will, but it will also take time. And so in the medium term, if we're having this conversation in 2030, hopefully it becomes obvious all of the things that are sitting in our rooms and on our bodies and in our bodies that are bio-derived, bio-manufactured. But it's going to take a lot of work between now and then to get there. And we're very excited to be in the trenches with everyone and part of that.
Well said.
Yes, well said. Joshua, thank you so much for coming on the podcast. Finally, it took us this long to get you on, but we're so happy to be in orbit with you, doing this together. We always love seeing you in New York City at all the events that we host and together. And we can't wait to see you again and chit chat about all the progress that's being made.
Thanks so much to both of you. Good luck navigating the blizzard this weekend.
Thanks.
Hey, this episode is sponsored by Messaging Lab. At Messaging Lab, we translate complex science and economics into compelling business narratives. And we have done so for the most successful biotech-forward companies across pharma, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice and elevate your business, visit us at messaginglab.com. Let's grow.
Iram, what did you think of this episode?
I was like, wow, I don't know what took us so long to get Joshua on. I mean, he's definitely a brother from another mother when it comes to talking about the power of bioeconomy. It was incredible. A lot of what he said across all the different projects. I was really impressed by how much effort that Joshua and his team have put into really deeply understanding what the challenges are for biology to commercialize. I mean, he talked about, and we'll go into this more because there's a lot to reflect on, but they are spinning up a biomanufacturing plant that's been a retrofit plant in Decatur, Illinois. There's also their partnership with Brentag, developing specialty chemicals through biomanufacturing. So people are out there, whether you have an innovation or you're looking for biochemicals, you can call it that way, or industrial biochemicals. This is a good program for you to look into. And then I really love the fact that he's writing. I mean, hello, we're talking about science communications here. We are doing it as we speak. Hello. That's what we're doing.
Yeah.
And I just love the fact that Joshua felt compelled to write The Great Formulation, a wonderful title, in response to what was going on with the ban of red dye that happened last year, or in the efforts towards creating new, I would say, non-toxic food dyes. Although I think in this episode, he really prefaced, it's like, well, there's still a lot of research being done on some of the chemicals that already exist in our supply chain, in our food and our products. But there's also a lot that's been pointing to some of these are toxic. So I think, the balance, it's not like everything made from petrochemistry is bad. That's not what we're trying to say here. But there's a lot of great functionality and experience that can happen through biomade products. So I just love the fact that there was a nice swath of activity. And then obviously we talked about the software that the team at Synonym has been developing, whether it's looking at fermentation capacity around the world and what exists, or to develop a techno-economic analysis or a life cycle analysis on what it takes to make a biomanufactured product. So it's a lot, but let's go into it. Carl, tell us specifically what your thoughts were about the episode.
What I really appreciated was Joshua reminding us that bio-based, bio-produced products are going to be a part of the global supply chain. And when it comes to this great reformulation, the opportunity isn't just to replace existing ingredients with bio-produced ingredients, but to replace them with ingredients that have higher performance. That's really the big opportunity. And we've talked about this a lot on the podcast, because the opportunity is, if you've got a replacement that maybe costs a little bit more, but the performance is better, people are going to buy it because people are looking for performance. So I always appreciate talking about that. And Joshua just put that so eloquently. He also talked about standardization, which is something that's really important when it comes to biomanufacturing. And he pointed out that it hasn't happened as quickly as expected. I think Synonym is only like 5 years old, so it's a very young company. And the standardization hasn't happened because the demand hasn't been there. So demand and standardization go hand in hand. But what we are hearing from people, and we're going to have in a few episodes, someone talk about this, that on the chemical side, people that are buying chemicals are asking for bio-based solutions or bio-based ingredients. So I think that that's something that speaks very highly of what Joshua and the team are doing.
Yeah, it's not just up to Synonym to standardize everything. You know, standardization of industry has to be coordinated across all efforts, right? So if you can't just have one company or one biomanufacturing plant using some standards and another manufacturing plant using another standard. It's a collective effort. You know, this is why we have all of the amazing things with digital technology, because there were standards. There are people behind the scenes saying, look, these are languages. We all have to use it. We all have to use these frameworks. We all have to do this. So it's easy for more people to innovate on top of that, or to make a smart purchase of things because everything is, you know, standardized. But to have this effort being led by Synonym or other organizations or coalitions would be a wonderful effort. And I, you know, we do see other organizations like Biomade here in the United States and other ones that are rallying for this. But I think it's really important because that is the groundwork. Because if you have the standards, it's much easier to scale a whole industry, not just one company.
Right. Absolutely. I mean, that's the reason why, as you said, digital scaled so quickly and so ubiquitously, because there were standards in place. And Josh was not the only one talking about this. Our friends at the Advanced Biotechnology for Sustainability Coalition are talking about this. And I remember early on, I say early on, meaning like probably 10 years ago, a video of Drew Endy kind of walking through a hardware store. Drew Endy is one of the fathers of modern synthetic biology. And he's in a hardware store looking at different screws and nails and how they are all standardized. And he's talking about how biotech needs that kind of standardization. So it's been something that's been talked about. We've probably made a lot of progress towards it, but we're not there yet. And then I will just close out by just saying one of the great things that Synonym has done is give us insight into where fermentation facilities are. And then, as you mentioned, the techno-economic analysis, making it much easier for people to figure out whether a product should be made with biology or not. So I really appreciate that Synonym has done that. And I know that a lot of companies that have worked with them have been very happy with using their tools.
Yeah, absolutely. And I can't wait to see what's next for Synonym. They have a lot of exciting things going on, as we talked about here, but we also know that there's going to be a lot more. They have a lot of data, they have a lot of insight, they have a lot of relationships. They've talked to the people that understand the demand coming from the consumer. But the big thing about demand is that people can't demand things that they don't know about. So
Exactly.
Here we are on the Grow Everything podcast talking about what is out there and what's available to people so that we can biologize a future. So here we are.
Let's go.
All right. So with that, Carl, are you going to read us out? Is there anything else you want to say?
No, I think that's it. What I'll say, is thank you for tuning into the Grow Everything podcast. You can find us on all streaming channels. People text us questions and we do answer. And you can find all our contact information in our show notes. Subscribe to our Substack and make sure you watch us on YouTube. Like and subscribe and comment. We'll see you next week.
That's the pod.